So I'll preface this talk. Those were 3 great talks before me, a few tough to follow there, but we'll transition to something a little bit different. Instead of supercells, we'll look at a little QLCS stuff here a little while. This presentation was kind of born out of for like a staff presentation that I put together to kind of show the warning, like the way to warn for QLCS as an NWS warning forecaster. We really haven't had a lot of these events in the past, according to John. So something a little bit different for us in this office. So good to put a presentation together to kind of get an idea to see how warning operations work for a QLCS tornadogenesis situation. So quickly here, I will take you through a Synoptic review, take it top down to give you kind of an idea of the setup, the background setup for that day. 300 millibars, we have a little shortwave over western Iowa that actually progressed through the night before. We'll be post-frontal when we go downstairs. You'll see that in a moment. The big feature of note will be the trough over the Intermountain West. Pretty good flow rounding the base of that trough, good upper level divergence. Locally, and you'll see this is a theme as we go down, flow is rather benign at this time across western Nebraska, but it will continue to increase through the day as that trough becomes closer and closer to the area. Step down to 500. Now you see a closed low over northern Utah, southeastern Idaho. Flow again much stronger upstream than locally. A little shortwave ridging across western Kansas, kind of keeping things quiet for the moment, and then a closed low over western Iowa. Down to 850. Again, a nice southerly flow noted. A nice broad low over the Rockies, hoping to promote that southerly level flow. Good moisture tap from the Gulf of Mexico. 30 to 35 knots, and the local jet still kind of cranking at this point early in the morning. And then again, as of note, that close low over western Iowa exiting the area. Head down to the surface. This is a quick analysis I did. Again, we're post-frontal after the system from last night. Actually, a pretty cool late May morning there in western Nebraska. Low temperatures there in the 40s in southwest Nebraska there at North Platte, 48. So pretty chilly start that morning. And again, you can see another big feature of note, the stationary boundary over southwestern Kansas, as we'll see as we step forward. That's going to look northward as a warm front through the day, and another surface low developing there over southeast Colorado that will continue to deepen, and then a cold front over eastern Wyoming. The biggest regimes of convection that were expected this day were along in the head of the cold front, and then as well as potentially a low-end scenario of some convection forming ahead of the surface low and along the warm front there in northern Kansas, southern Nebraska. So we'll step ahead to 21Z, very different environment out across the area. At this time, the surface warm front has lifted north quite a bit. You can even make the argument that it's a little bit farther north, and I have it plotted there at 21 Zulu. But mid to upper 60 dew points, not too far away from the region. A dry line has slowly lifted northeast into southwest Kansas as the surface low continues to deepen over eastern Colorado, and the surface cold front has not progressed much over eastern Wyoming, western Nebraska. So here is the 0Z LBF sounding from that evening. This will be a few hours before the potential QLCS tornadogenesis occurring just off to the north of North Platte, across the Sandhills. We are in the vicinity of the warm front at the time of this sounding, may still be just along it. Really good steep level lapse rates, a little bit of a cap holding on, but nothing that's too strong to be broken by any sort of the cold front or anything like that. Good turning in the lowest 3 kilometers with a lot of speed shear above. And again, that just kind of continues to strengthen through the late evening hours as that trough continues to progress into the area. Here is the afternoon SBC outlook. I'll just kind of go briefly through this. Basically, the SBC's thinking on this day was supercells, potentially initially along the cold front in far western Nebraska, eastern Wyoming, that would congeal into a line as it progressed eastward. And you can see potential for some severe down the dry line in Texas, and then ahead of the surface low, there's enhanced risk across eastern Iowa and Illinois. Tornado outlook, nothing too crazy for our area. In fact, the area in question was not outlooked for tornado for this evening. Again, they were a little bit more worried about a potential supercellular threat and potential tornadic development with that, and not necessarily with the congealing line as it progressed eastward. kind of broad 15% for the wind. Again, nothing too focused. And then the only difference in the hail outlook would be a little area of hatched hail over southwest South Dakota, western Nebraska, which again is covering the threat for the potential for some initial supercells to come off the higher terrain ahead of that cold front. So a quick brief review of the three ingredients method. This is the three ingredients that NWS forecasters look at during warning operations to see if a QLCS could potentially become tornadic. So the big deal is we need a system cold pool and ambient level shear, nearly balanced or slightly shear dominant, a 0 to 3 kilometer line normal bulk shear magnitude of greater than 30 knots, and some sort of rear inflow jet or enhanced outflow surge to cause a surge of boat within our QLCS. So we'll kind of step through each three of these ingredients with the QLCS and kind of get an idea of maybe which ingredients are or are not there. So we'll start with ingredient one, which is system cold pool and ambient low shear, nearly balanced or slightly shear dominant. Just to orient you, top left, reflectivity, top right, storm relative velocity, bottom left, base velocity, and bottom right, spectrum width. Spectrum width in this case showed the updraft, downdraft convergence zone very well, so I've used it for a little bit of the presentation here, and I'll get a little bit more zoomed in look here on the next slide. So basically what we're seeing here, the takeaway, they're the southern portion line, and again, for most of these images, and I think all of them actually, the radar, the RDA will be just off to the right-hand side of the screen, off to the east of the convection. So to orient you there, west of Tryon, we can see the outflow has surged out ahead of the line, and we're very cold pool dominated. Though as we go north into portions of Hooker County, they're south of Mullen, we are getting a lot closer to balanced. Tough to really say for sure whether we are or not, but at least very close to balanced. And then again, it gets to be a little more cold pool dominated north of Mullen. So again, as I kind of reiterated, spectrum was showing that UTCC the best. Hooker County segment seems to be pretty close to balanced, though it could potentially be marginally cold pool dominated. So this was the weakest of the three signals that we found. So moving on to ingredient two, which is our 0 to 3 kilometer line normal bulk shear magnitude greater than 30 knots. So if we look across the Sandhills there in central Nebraska, we have bulk shear on the order of about 30 to 35 knots, mostly from the west, just a touch southwest maybe, where we're kind of looking here across the Sandhills, and we definitely have adequate shear strength greater than 30 knots. Also overlaid there, just a note, is the MO Cape at this hour, which again shows a very unstable environment still, as we are near to just after dark at this point. So still very unstable, and the ingredient two does appear to be met. So one, marginally, two, definitely, we'll move on to three, and that is the rear inflow jet or enhanced outflow causing some sort of a surge of a boat within a QLCS. In this case, we believe it to be outflow driven. Definitely no obvious rear inflow jet at any point during this case. So we believe ingredient three is definitely being met with some sort of enhanced surge. We believe it's being caused by some sort of an enhanced outflow. Another thing to take note, I was working this night, there in the bottom right-hand side of the screen, that was our primary focus in operations at the time. The supercell kind of formed along that surface warm front, looking northward, and it produced an 86 mile an hour wind gust at our AWAS in Broken Bow. So at the time, a majority of our focus in operations that evening was on the supercell and not on these subtle features in this QLCS. And as we look forward and you look at how subtle some of these things are, it really shows how situational awareness is so important, because you can miss some of these subtleties if you're not really, really looking closely. So again, just to kind of to reiterate my points there, there's surge, never clear any clear rear inflow jet, but potentially outflow driven with this surge. So all three ingredients are met at least marginally prior to any of these signatures appearing. Once again, ingredient one, a little tough to say, potentially marginal, could probably look into that a little more. And we'll go ahead and head to confidence builders and measures. So these are the next confidence builders and measures. We need 4 to 5 as a general rule for a tornado warning. And again, much like the first three ingredient method, I will take you through the few that I found and kind of show you examples of what we have for the potential need for a tornado warning. So the first one, enhanced surge, I won't bore you with the radar again, as we saw that earlier. So as it's a confidence builder, we'll go ahead and check off one confidence builder with an enhanced search across Hooker and Thomas counties. So the next one is a reflectivity nub. And this would be, we had at least 2 of them that had a pretty well-defined reflectivity nub right on the front edge of the convection. And I'll show you these in just one moment. And just as a heads up, we were in, I don't remember exactly which, some sort of a sales or Merle cut. So the velocity images and reflective images don't necessarily locationally match exactly due to these differing scan times. So this is the first signature. This is across far southern Thomas County. This is probably one of the better signatures that we had this evening. Pretty obviously a front reflectivity nub there, co-located with a pretty tight velocity couplet. They're just to the southwest of the radar. Here's signature 2. Again, this one's a little more subtle with the velocity couplet, but some sort of a front reflectivity nub there just ahead of that signature. This is probably the most marginal of the 3. Again, kind of co-located with that velocity couplet. Potentially one there, tough to say for sure, but at least it is co-located with a velocity couplet, so marginal at best. So we'll move ahead. The next confidence builder we'll look at is a tight, strong mesovortex with V sub r greater than 25 knots. So we'll look at these 3. We'll calculate V sub r. I didn't put the distances between, because all of them were pretty tight, usually about 1 nautical mile or less. So very tight circulations. So the first one, again, probably the most obvious of the 3, when calculating V sub r, about 40 knots. So pretty good inbound outbound signature there, pretty close to the RDA, within probably 20 to 30 nautical miles of it. So very strong V sub r, right around 40 knots. So that one's met. We go to the next one. Again, a little less strong, but still meeting that 25 knot threshold of around 30 knots. And then the third, more marginal one, again, right around 30 knots. So all 3 are hitting that confidence builder. So, we're meeting that mesovortex confidence builder threshold, so we're starting to build them up now. So we'll go ahead and push forward, and this is another measure here. So this will be 0 to 3 kilometer MLK greater than or equal to 40 joules per kilogram. So this is the 0304Z MLK, 0 to 3 kilometer MLK from the Spc mesoanalysis page. And obviously across the Sandhills, very adequate 0 to 3 kilometer MLK at this time. So this measure is obviously met. Again, this kind of just shows that keeping situational awareness with even the SPC mesoanalysis is really important, because this was one of the measures that pushes over the top for the potential for a tornado warning. So as a quick aside, it appears that all 3 ingredients were met, as well as 4 confidence builders and nudger, making the 3 couplets potential candidates for tornado warnings. There's a really complex interaction merger occurring there. We're not really sure. I know John and I have talked about this case in depth, and he sent it to a few of the TWIP team members. And there appears to be potentially a brief quasi-supercellular transition as it kind of propagates off to the southeast. And that southeastward motion is very anomalous. We're likely tying it probably to that quasi-supercellular transition, though that's unclear. We're not really sure what's driving that for certain. As for any sort of confirmation, we did have 1 damage report along the Hooker-McPherson County line. And if I go back here, I believe it was with this signature here. So it wasn't even our strongest signature, though I will preface this with, this is portions of the Sandhills, and Hooker County, Nebraska is one of the least populous counties in the entire country. So not a lot for population in these areas for any sort of confirmation of anything. But with this signature here, we actually had 1 damage report. I took this call of 2 large trees down. The health of the trees were pretty questionable. They said they were dead or mostly dead. So tough to say for sure what caused that, if it wasn't maybe some sort of more straight line wind in nature, or potentially tornadic. But nothing was ever confirmed with any of these signatures, so uncertain if a tornado actually occurred. And again, a quick summary there of, the event showed the importance of situational awareness. We in ops were really worried about the supercell. A lot of these subtle signatures can really fly under the radar, no pun intended there, when you don't have a real good handle of looking at these things very closely. So what did happen? Again, here's a quick SPC report map for that evening. A lot of hail reports across RCWA. There's a significant wind report at Broken Bow there across central Nebraska. And then this thing really became a pretty good wind producer as it got into eastern Nebraska with a lot of significant wind reports and such. A lot of tornadoes ahead of that surface low over in eastern Iowa and Illinois as well. So a pretty busy, severe day for quite a bit of the CONUS. With that, I will go ahead and yield my time and ask for any questions.
Thank you, Caleb. Again, the floor is open for anybody. If you have a question, go ahead and unmute yourself and ask away. Well, I'm not hearing any, and so I guess we'll move on to the next talk. Thanks again, Caleb.
Sorry, I was waiting to see if anybody, because as Caleb mentioned, we've talked about this case. I was kind of waiting to see if anybody else jumped up there. You know, I'll always ask questions, but just more of a comment, really. Thanks, Caleb, for the great talk. Of course, I've seen it before, but parts of it anyway. I really like that you pointed out those the situation awareness part of that, because that is huge, and the need for getting some sort of a split of duties there, radar duties, to focus on two different entities that are occurring at the same time. What I'll also say is, you know, with the VROT signatures, obviously that's one of the concerns, you know, and part of identifying these particular mesovortex cases is, you know, we're really looking at these tiny little snapshots in time. And so again, how you are oriented to the radar may make, and the fact that you're only getting a snapshot may make all the difference in those subtle velocity signatures, and whether they show up nicely at all. So again, appreciate you looking into this case.
Of course. Thank you for the comments. Those are all very, very good points.
All right. Well, thanks again. I don't see any other questions. Again, thanks for your talk. I really enjoyed that. We're going to change gears a little bit now. We're going to skip the break because we're almost back on time. And we're going to kind of focus more on mesoanalysis and forecasting type techniques here. So the next speaker up is Jordan Thies. He's going to talk about the role of mesoanalysis on message